Hello, myself Mr. Niraj Patel. Today I am going to explain a two-in-one combustor and heat exchanger. So here's the first figure of the steam power plant. Cause effect analysis of steam generator. First, combustion is the primary cause. Steam generation is an ultimate effect. Heat transfer is a mediation. Combustion causes the generation of heat inside furnace volume. Heat generation causes the production of high temperature gases. These high temperature gases cause the radiation and convection heat transfer processes. Heat transfer processes carry the thermal energy to furnace wall and steam tubes. Conduction through the tubes and walls cause the convection inside the tubes. Convection caused the generation of steam. Few hundred years of ignition trials lead to a scientific technology. Here's a photo of a 720 Haycock shell type boiler made of copper plates, as you can see in the figure. Then water tube boilers with steam generators. An industry developed during 19th century, so the use of boilers for raising steam become widespread. Disastrous explosions sometimes occurred. Boilers of that point consisted of heat pressure vessels of large diameter. These are subject to internal pressure, which is tensile stress in the walls of enclosure. The value of stress known as hoop stress is given by F is equal to P into D by 2T. Then steam generator versus steam boiler. Opposite the principle of steam boilers, the water in the steam generators evaporates inside the tube wide up into the serial conducted tube coils. The feed water is heated up to the evaporation temperature and the evaporated. The intensity of heat, the fed water flow, and the size length of the tube are adapted so that the water is exactly full evaporated at the exit of the tube. That this ensures a very small water and steam volume content of the pressure vessel. Thus, there are no buffer in a steam generator and it is temporarily overloaded. Advantages using a steam generator compared to conventional steam boilers. Easy to operate, normally no requirement for boiler authorization, rapid startup and stabilizing full steam pressure, compact and easy to adapt in the existing machinery arrangement, primary attractive, especially at low steam rates. Here's the body of the power plant steam generator, as you can see. Then thermal structure of a subcritical SG, and here's a photo of the superheater pendant. Then the steam generator, the water tube boiler. As you can see, the water tube boiler below looks very complicated. Thus, of tubes are placed in strategic location to optimize the exchange of energy from the heat to the water in the tubes. These types of boiler are most common because of their ability to deliver large quantity of steam. The large tube-like structure at the top of the boiler is called a steam drum. As you can see here, the hundreds of tubes starts and eventually end up at the steam drum. Then here's a steam generator theory. Within the boiler, fuel and air are forced into the furnace by the burner. There it burns to produce heat. From there, the heat fuel gases travel throughout the boiler. The water absorbs the heat and eventually absorbs enough to change into a gaseous state steam. To the left is the basic theoretical design of a modern boiler. Boiler makes have developed various designs to squeeze the most energy out of the fuel to maximize its transfer to the water. First, water enters the boiler preheated at the top. The hot water naturally circulates through the tubes down to the lower area where it is hot. The water heats up and flows back to the steam drum where the steam collects. Not all the water gets turned to steam, so the process starts again. Water keeps on circulating until it becomes steam. Meanwhile, the control system is taking the temperature of the steam drum along the numerous other readings to determine if it should keep the burner burning or shut it down. As, as well, seniors control the amount of water entering the boiler. This water is known as fed water. Fed water is not your regular drinking water. It is treated with chemicals to neutralize various minerals in the water, which untreated would link to the tubes, clogging or worse, rusting them. This would make the boiler expensive to operate because it would not be very efficient. As you can see, there's a figure in the right hand side. So steam generator theory, fire side. So it's about the fire burner. On the fire side of the boiler, carbon deposit resulting from improper combustion or impurities in the fuel can accumulate on the outer surface of the water tube. This creates an insulation which quickly decreases the energy transfer from the heat to the water. To ready with this problem, the engineer will carry out shoot blowing at a specific time. The engineer uses a long tool and insert it into the fire side of the boiler. Scaling of steam generators. This blowing action of the steam scrubs the outside of the water tubes, cleaning the carbon buildup. Water tube boiler can have pressure from 7 bar to as high as 350 bar. The system temperature can vary between status steam 100 degrees Celsius steam with a particle of water or be as high as 600 to 650 degrees Celsius, known as superheated steam or dry steam. The performance of the boiler is generally referred to as tons of steam produced in 1 hour. In water tube boiler, that could be as low as 1.5 ton per hour to as high as 2,500 ton per hour. Once through subcritical steam generator. So once through cancer line fixed max continuous rating is 520 kilograms max steam and temperature outlet is 540 degrees Celsius. Live steam pressure is more than 8.3 megapascals. Here's the picture of them, as you can see in the figure. Design steps for steam generators. Uh, Thermodynamic design, air fuel ratio, specific size, outlet, efficiency, thermodynamic parameters, heat transfer based design, surface area of various parts, material used for various parts, geometry of various parts, detailed temperature distribution, and construction details. Design steps for steam generator, hydraulic design, pressure distribution, or drop in various parts, velocity distribution, hydraulic parameters, design optimization, mechanical design. Steam generation specifications, steam, flow rate, pressure and temperature, we add water, economizer, inlet temperature, fuel type, ultimate analysis, heat value and physical properties, sorbate, emission, SO2, NOx and particulate, then pressure drop, soil waste, ash deposit system, auxiliary site, personnel, evaluation criteria, special parameters, heat recovery SG, fuel gas amount composition, gas temperature at inlet, back pressure of turbine pinch point, then preliminary design, useful for estimation of budget price, detailed proposal design, essential for making a detailed competitive bid, final design used in presentation of manufacturing drawings. Then preliminary, first analysis of various control volumes, input, steam condition and fuel analysis, database, design data of previous plants, procedure, interpolation and extrapolation of post data, overall size, weight, cost of the plant, commercial software packages available, then detailed proposal design, detailed study and review of parameter of the SC stream, fuel environment, thermodynamical design, heat transfer based design, hydraulic design, design optimization, mechanical design. Thank you very much.